All right, so I can cross that one off the bucket list.
First day on.
I'd watch it a second time. Absolutely. I do every day. And you know, what I find so important about Star Trek is not only the adventure and the excitement and the storytelling, but that it said through technology, through space exploration, we can build a better world, a better society, that we can make life better for all of us. And what we're here to talk about today is how space exploration, the space program, is going to dramatically improve life on Earth. When I was at NASA, I was being interviewed by a BBC reporter that was asking me, how can you justify spending billions on space exploration when we have existential threats that we're facing, like climate change? And I had to explain, if it wasn't for our satellites, our remote sensing capability, we wouldn't be even understanding what climate change is. As a matter of fact, this was a BBC reporter. We couldn't even have the conversation if it wasn't for telecommunication. And I don't think we talk enough about how we can change the world for the better, how we can feed the hungry, how we can cure the sick through the advances that we are getting through the space program. So we're going to do a lot of that today, and I'm incredibly grateful to have such an amazing panel to talk about this topic. So to introduce them one at a time, I really am pleased to have Rich Boling with us. Rich is the Vice President of Corporate Advancement. Come on up, Rich. Leads business development for the company's biotechnology and materials science, which includes Redwire's biofabrication facility, the BFF. I love the names that we have. He's contributed to dozens of payloads, including those flown aboard parabolic flights, suborbital rockets, space shuttles, Northrop Grumman, Cygnus, SpaceX, Dragon, cargo and crew vehicles, and on the International Space Station. Next up, we have someone who is creating that inspiration, the dream for all of us, Jess Bush. Jess, if you could come to the stage. Jess has been a visual artist since childhood. In addition to the visual arts, she's done modeling. She's a Saturn Award-nominating actor, appearing in my favorite science fiction series, and pulling off the nearly impossible feat of reviving and redefining a classic character from nearly 60 years ago. She's continuing a proud tradition of actors from this particular franchise becoming involved in supporting real space exploration. So thank you for being here, Jess. Next up, we have the Dr. McCoy of our panel, Dr. Kris Lehnhardt. If you could come to the stage. Kris is an element scientist for the Exploration Medical Capability, which is part of NASA's Human Research Program. Kris serves as an associate professor with the Baylor College of Medicine, the Center for Space Medicine, and the Department of Emergency Medicine. He is also an adjunct faculty member with the International Space University, a fellow of the Aerospace Medical Association. Kris Lehnhardt is board certified in emergency medicine in both Canada and the US. So welcome, Kris. And then finally, we're truly honored to have Dr. Anna Fisher. Dr. Fisher, if you could come to the stage. She's a retired NASA astronaut, a chemist, an emergency physician. Dr. Fisher was selected as an astronaut candidate with NASA Astronaut Group 8, the first group of NASA astronauts to include a woman. She became the Astronaut Office representative for the development and testing of the Canadarm remote manipulator system, the testing of the payload door, contingency spacewalk procedures. As the first mother to go to space, Anna flew on the Space Shuttle Discovery, during which she used the Canadian robotic arm to retrieve 2 satellites that had been placed in incorrect orbits. After retiring as an astronaut, she remained active with NASA, supporting the International Space Station Orion, a true trailblazer who has done so much for all of us in this industry. And I'm going to say the mother of Kristen Fisher, my favorite CNN reporter. Let's have another round of applause for everything Dr. Fisher has done to open up doors for all of us. So thank you, panel, and let me turn first to Dr. Fisher. Anna, in fictional works, we see all kinds of advanced technology that ensure the health and safety of space explorers. Based on your experience today, what do you see as the critical needs that we need to look at and develop as NASA and the private sector go out further into Earth orbit and to the Moon and Mars? What are the developments you think we need to have?
got it, I think.
Space is the easy part. Getting the mics to work, that's the...
I needed a checklist. Gosh, I think, that I think we're actually on the right track now. I've always thought that going back to the moon first is what we need to do, but ultimately I think we want to go to Mars. And in doing all these things, we will wind up pushing technology and learning things that we don't even know. I mean, there's so many things we have to solve. When we went to the moon back in the 60s, that was a miracle in itself with the computers they had and the amount of memory. But now I think we have the technology to do all that. But now to learn how to live on the moon, grow your own food, practice medicine in a reduced gravity environment, in an environment with no atmosphere, to learn all those things we need to learn in order to go on to Mars. And so that's what I'm really excited about, because really everyone in our class thought that by the time we retired, we would have already been to Mars. So when we were selected in 1978, I don't think any of us would have thought that it would be this long, and we still hadn't done that. But then there's so many things we have to learn to do that. How to protect ourselves from radiation, how to, the propulsion system, how to keep crews in good health, because you lose muscle mass and bone density. And we've had this problem with people's vision deteriorating. So we've got a lot of research, a lot of things to learn. And ultimately, those things always wind up coming up with benefits for things for people here on the ground.
Continuing along those lines, maybe tell us a little bit what it's like when the astronauts come back from the ISS and some of the challenges that they face. And then as we look at the Artemis mission to the moon and Mars, what do you see as the intransigent or difficult issues we're going to need to overcome?
Right now, when the astronauts come back from the space station, we've actually become very good at taking care of people in space. Compared to the past, with all the advanced nutrition, exercise devices, and monitoring that we do in space now, when people come back to Earth, they aren't as deconditioned as they used to. And so as a result, we're starting to Anna's point, we're starting to really learn how to live and work in space for periods of time. But the moon and Mars present a unique challenge. And the reason that it's unique is because our experience right now, we have had people every day of the last 23 years on the International Space Station. And those people are not that far away. They may seem like they're far away because they're in space, but they are 250 miles above us. So their proximity to Earth is quite close. So as a result of that, we have all kinds of benefits. On Thursday of this coming week, there's going to be a resupply mission that flies to the space station so we can resupply those missions. We have real-time communications with the astronauts on the space station. We have people in mission control who every minute of every day can essentially talk to the astronauts real time. And because of our proximity to Earth, we have the ability to bring people home if something bad happens. So if a medical emergency were to occur in space, we can have people back on the ground pretty quickly, in the order of hours to a day maybe. The moon, 3 days away. Mars is 9 months away. And so our Earth proximity makes us Earth reliant. And one of the wonderful things about the science fiction world that we want to achieve someday is that it starts becoming more Earth independent. And so for our Artemis missions, what we have to do from a medical perspective is we have to learn how to be Earth independent when we don't have resupply, when we don't have real-time communications, and when we cannot evacuate somebody on the way home.
Kris, you have to tell us the Diet Coke story real quick, though, that you shared with me over lunch, the dropping.
One of the things that astronauts tend to do when they've been up there for a long period of time is they get really used to the space environment. And so I'm going to borrow water here. So they'll come back to Earth, and when they're in space, they just let go of things, and they don't move. But when they come back to Earth, they forget that they're not in space, and they just let go of things, assuming it's not going to go anywhere, and then they get reminded that they're back in gravity again. So it's readjusting to Earth is is a challenge.
So if you see astronauts dropping things, let's all forgive them. It's just all part of recovering from the experience. So thank you, Kris. Jess, if we could turn to you again. You and your colleagues have done so much to help inspire, to explain, to bring the vision and the hope and the optimism of space and space exploration to the public. As an artist, could you talk about the important role of the arts and artistry to space exploration and how you see that interaction occurring?
What about now?
Sharing and cooperation, all an important part of space.
Yeah. Well, I happen to believe that the arts in space is important for several reasons. First of all, historically, arts has always preceded progress in the space industry, essentially. Works of fiction have always blazed the trail for real-world transformation. Artists are able to kind of develop visual languages for people to imagine and participate in new collective identities, to see things that weren't there before, to draw links between things that they might not have seen in the current framework that they have for what's possible. So that's one thing. Second of all, as using an artist's point of view to approach problem solving, I think is extremely helpful. When you are approaching things from the mind of an artist, you enter into a space of curiosity and play. And it's been proven that that's space, as human beings, that's the space where we learn the most effectively and retain the most information. Also, when you're coming at something as an artist, you're searching. When you're coming at something as a scientist, I imagine you're also searching. When you're an artist, there's no boundaries to your search. There's nothing, there's no incorrect or correct way to do things. There's no rules. So you're able to kind of try out everything. Have them all as a bouquet. So again, project maybe? You guys can probably hear me. Hello.
There you go.
Wow. Hello? Yeah.
There you go.
Okay. So it's a fabulous way to problem solve because you're able to see things that you might not have seen before, and make wacky connections that you might thought of being silly and then on the way you might discover something really useful. And thirdly, this is the part that I'm really interested at the moment with the space industry and the arts, is that art is a really powerful tool in times of great social transformation, in times of social evolution. It can be very orienting. Artists are able to, as I said before, they create visions for us to connect with and see ourselves to identify in like new ways of being. And I think right now, with so much change happening in the space industry so quickly as a result of privatization, that we're coming to an inflection point where lots of different things could happen for us in the direction, like in the way of the direction that we're moving the space. And I think that not all of those directions are in pursuit of greater equality, of greater stewardship of the planet. A lot of them are, but there are opportunities for us to go off track with that. And I think that the artist plays a crucial role in shaping the cultural story of space exploration and giving us a shared vision to connect with, to keep us ideologically on the right path with that. And I will kind of give you a historical example that's been recent where an artist has been extremely influential in this way. I don't know if you guys remember Obama's campaign in 2008. He had this very iconic poster that said "Hope" across the bottom. If you don't remember it, just Google on your phone "Hope Obama" and it'll come up. There'll be hundreds of versions of it. So anyway, before that poster came about, Obama was polling negatively. And this artist, his name is Shepard Fairey, he's a very prolific street artist, and he wanted to come on board and help. So Shepard Fairey wanted to paint Obama as this everyman, this very relatable person who was patriotic, but also had vision and was very progressive and aspirational. So he painted him, he deracialized him, he painted him in blue, white, and red, and he positioned him in the frame with this tactic that filmmakers use, where, you know, the human eye reads from left to right. So he's placed in the frame on the left, looking upwards towards the right. So the human eye reads that as someone looking out to the future. So Shepard Fairey used his skills in visual language to create a very simple but very powerful image of this person that could be copied infinitely, distributed infinitely and instantly, and digested by anyone and understood by anyone across all social divides, across gender, age, cultural barriers, gender, I already said gender, you know what I mean. Like, it was understandable across the board. And it was widely considered to have a huge impact on his success. And it was a hugely influential piece of art. It was actually said to be the most efficacious political poster since the Uncle Sam Wants You poster. So, you know, artists are able to engage us on a physical, emotional, philosophical, intellectual level at the same time. And for that reason, they're able to impact us much more deeply than just intellectual information. So that power, I think, should be taken really seriously, and we should be aware of its influence and use it for good.
So to summarize, through artistry, we can have a future that's more Star Trek and less Star Wars.
Exactly.
Is what we're
Yeah, it can
shooting
also be a
for.
signpost. You know, you can look to art to reflect where we're going and notice things that you don't feel good about with that. So it can work both ways.
So Jess, are you volunteering to go, the first artist in space?
Ooh, every time someone asks me that, I get like a pang of fear because I'm terrible with heights, and that's just terribly
Uh-oh,
scary.
yeah, that
but,
could be a problem.
but I of course would. I would have to go. I would have to taste that so that I could dedicate my skills as an artist to sharing the expansive nature of being up there and the different understanding that it would give me of our precious, precious Earth. I need to share that.
And we talk about the different understandings. So the term that we use to summarize that is the overview effect. And as the astronaut on the panel, Dr. Fisher, I'm just wondering, did you experience the overview effect? Did you view the planet or humanity differently after coming back from space?
Definitely. You know, when you first get a chance to look at the Earth from space, it really does change your perspective. You know, you'll pretty much every astronaut and taikonaut will tell you that, because when you look at this beautiful planet and then you look at the vast blackness of space, and you realize that for the very foreseeable future, it's going to be a long time before we have any place else that we go to survive. And you just start to feel of yourself as being from planet Earth, as opposed to being, you know, from your respective countries. And one of the things that I love about the space program is it tends to unify people. I mean, even now, with everything going on in Ukraine and the problems we're having at the higher levels of government, nonetheless, we're still launching astronauts on the Russian Soyuz, and we're still launching cosmonauts on the U.S. SpaceX. So in Mission Control Houston and Mission Control Moscow are still working together. I'm still not sure I quite understand how that happens, but it is, and that's what I love about space, how it unifies and brings people together who have a dream and a passion. But you definitely start to think of yourself more as a citizen of planet Earth, and you really start to realize that Earth is like a spaceship moving through space, and that we're all linked together, and that we really need to take better care on both of our planet and of each other. And in the times that we're in right now, we certainly need a lot more of that quickly.
Space certainly does unify us in a way that really nothing else in the world does globally. And having worked previously as a diplomat, what I think is so important about space, as you mentioned, Russia, China, during the difficulties we're facing now, the space program will likely be the last remaining means of communication that we have with adversaries, while linking allies together for all the challenges that we're seeing now in the Middle East. I'm so proud of what NASA and the Department of State and the White House have done with the Artemis Accords, that Israel, the United Arab Emirates, Saudi Arabia, Bahrain, all together supporting the Artemis program. I just don't think there's any other field of endeavor that can do things in that way. And Dr. Fisher mentioned the challenges that we face with the planet and climate change. I talked about the importance, the vital role that NASA and commercial space had played in terms of monitoring climate change, trying to understand climate change. You know, Jess, you've done some terrific work, if not on the climate issue, on the artistry of that. Could you maybe say a quick word about your Totem project and what you've done with that?
Sure, I would love to. Yeah, so before moving into the theatrical world, I have had a whole life as a visual artist, and I still do. And my magnum opus, I guess, up to this point, I don't know, maybe I'll make something bigger later, but this piece that I built took me a year to do it, and I collected 1,000 bees after they died from out of the grass. I would visit beekeepers and collect little dead bees from them, and I preserved each one in a perfect sphere of crystal resin, which is very difficult, can confirm, and then suspended 1,000 of them from the ceiling using really fine sterling silver jewelry chain from a grid, and it looks like kind of like a murmuration of birds, but like a perfectly engineered in a computer murmuration of birds. And each sphere kind of magnifies the bee. I also got a sound artist to create a soundscape for it, and got a light projection artist to project light onto it, and it was unbelievable. So yeah, that's the piece. I don't really like to tell people what it means, because that's up to you to discern, but there are some aspects of it that I like to kind of talk about, and that I like. It is at one with the environment. So when it changes according to the environment that it's in and the time of day and the people that are around. So it'll like look completely different with the changing light of the day. If you visit it in the early morning, it's dead still, so it looks like it's almost solid. But then as more people start to get up and make sound, and there's more birds and there's things moving around in the air and making sound waves, you'll start to see it kind of vibrate. So I love that it is one with the part of an ecosystem, I would say. There's another factor that it looks like it's engineered in a computer, but that is because one human being has focused all of her attention on making it perfect. So there's something about the synergy of technology and human ingenuity and focus that I really love, coming together and making something positive and impactful. And the third thing is, of course, that bees, to me, represent, they kind of have become the poster child of where we're at with our relationship with the planet. They're a species that is the linchpin of the ecosystem that supports us, supports life for us, and they're struggling because of the ways that we have treated the planet. So those three things kind of come together in a way that will make you feel however you feel.
I've seen it. It's amazing. I won't tell you how to feel about it beyond it's worth checking out.
Thanks, Mike.
And anytime, Jess. And, you know, Jess is talking about healing the planet through space, the overview effect. Rich, the work that Redwire is doing is literally healing people, and was very proud to see the company print the first meniscus in space successfully several months ago. And Rich, could you maybe talk a little bit about the benefits of microgravity for biotech, for medicine, and more specifically, some of the payloads that are going up on CRS-29?
So in some ways, removing gravity from biological process is like taking a mask off those processes. So you can observe things that are more difficult to observe on Earth. So from a research perspective, that's really valuable. From a manufacturing perspective, referring to the 3D bioprint of the human meniscus we recently did, we're striving for a day at Redwire where those people, 22 people a day are dying on organ donor waiting lists, which is 21 is too many, right? So 22 is really difficult to bear. But we've developed a process for manufacturing tissues, eventually whole organs in space. And that process is just not possible at all because you have sedimentation, there's convection. On Earth, if you were to bioprint a thick bit of tissue, one layer, some layers near the top may be too heavy and they fall to the bottom of the dish or whatever you're building. Space, we can bioprint layers that are not much thicker than water. They all stay exactly where you put them. We can't bring them right back to Earth. We have to culture and condition them over 3 weeks at least. Then they're strong, tough enough to come back, and will be safe for transplantation eventually. That's the world we're striving to live in a way of life imitating art, where you've had replicators in space, and or they have replicators. Some science fiction works.
I can neither confirm nor deny due to the SAG-AFTRA strike.
So we've had the first 3D plastics printers in space, Redwire, now the first 3D bioprinters. So again, we're striving toward that day where you can go to space to benefit life on Earth.
I mean, so much of this was the realm of science fiction not too long ago. And to hear about these ideas, the innovations, the dreams coming to fruition is amazing. And kudos to yourself and the team who are taking these concepts, transforming them into reality. And Rich, you mentioned replicators. And I know, Kris, you're a pretty big science fiction fan. Would you maybe want to say a word or two about the impact of science fiction on you, your career, and what NASA's doing these days?
I am a very large space nerd in general, but science fiction is where it all started for me. And I remember sitting on the floor in front of a television watching reruns of science fiction shows with my mother, and that having a profound impact on me. And I can actually go back and find little drawings and things that my mom has kept since I was a kid, and they were full of spaceships. And then I got to sit on the floor again in my second grade classroom, all in a big circle, and I'm dating myself now, but our teacher would roll in a television and plug it in, and we sat there and we watched a shuttle launch. And for me, that was a defining moment, because it was, when I had seen these things on TV, I knew they were fiction, but I was still inspired by them and I loved them. But then suddenly I saw that, wait, this isn't fake. This is real. We are actually doing this. How can I be a part of that? And when I was a kid, I very much wanted to be a veterinarian. And my mom, quite correctly, because I loved animals, but she said, don't you love space? Don't you want to kind of try to go to space or do things in the space industry? And do you think there's a lot of veterinarians in the space program? Yes, exactly. One. Those are not good numbers. So I was like, that's a good point. So what I did is I looked at the profiles of astronauts, and I saw that some of them were doctors. And I was like, maybe if I become a doctor, then I can be an astronaut and I can go to space. And so I essentially switched species, decided to go to medical school, and decided to pursue space and space medicine as my career. And that wouldn't have happened if it hadn't been for those original reruns of old sci-fi shows.
Thank goodness for reruns. You know, Dr. Fisher, curious your story as well. As an MD, were you influenced by science fiction? Did you always have an interest in astronautics, or how did you come to the career path that you did?
I was a little different from me. Reading when I was young, but there were no science fiction books that had women as the central character. And for some reason, when I was young, I couldn't read a book. I couldn't relate if it didn't have a female main character. So I wasn't reading a lot of science fiction or watching it. For me, I was just a nerd when I was young. I loved math, I loved science, and I was 12 years old listening to Alan Shepard's first launch. we were crowded around our PE teacher first thing in the morning, and with a transistor radio. We didn't even have a TV. And many of you probably don't even know what a transistor radio is. But listening to Alan Shepard talk to mission control, and at that point I decided that is what I want to do someday. And I never lost that dream, but it didn't seem very realistic. Women weren't allowed to join the military and fly high performance jets, and that actually just never occurred to me. But I did think, well, I could, kind of like you, I could eventually combine my love of math and science with becoming a doctor. And although I didn't mention it at my medical school interview, in the back of my mind, I said, well, maybe someday I can be a doctor on a space station, and at least if I don't get to be a career astronaut. So the seeds were planted. I did love later science fiction, Star Trek, Star Wars. I'm one of those people who like both of them. And a little bit, I just have always been intrigued by space and just wanted to be a part of it. Never really thought I would have a chance to become an astronaut, really, because that seems like such a far-fetched dream. And just on a chance conversation with one of my medical school friends who had seen this ad that NASA was looking for not only pilot astronauts, but for mission specialist or scientist astronauts. It was about 1 month before the deadline. And it took in those days about a month to get everything together, because you had to do everything with snail mail and get an application and actually fill it out. You didn't just jump on the internet and apply. And I got my application in 1 day before the deadline. 6 weeks later, I was in Houston interviewing for the job I always dreamed about. And 6 months later, found I was in the first class of astronauts selected for the shuttle. So it always kind of boggles my mind when I think back that your whole life can change on just a chance lunchtime conversation. And so, and I've just been incredibly blessed ever since to have an amazing career and get to have a family as well. So it was just, the whole experience has been wonderful. And I wouldn't trade places with anybody in the world.
So glad you had lunch that day.
I would always think about, like, what if I hadn't been hungry? Yes, it's years later, I was made the godmother of a Viking ship, and I got to invite all my friends to the shakedown cruise. And I invited Dr. Mark Mizakowski, who is my friend. I had a chance to thank him for changing my entire life.
Well, you've changed so many lives as the trailblazer for women, for mothers in the space program. Any advice you would give to young women who are coming up to study STEM or to participate or are already at NASA?
Goodness, yes. Well, first of all, there's just, you can just read the astronaut biographies. The more recent women that have been selected, their resumes are incredible. But, now you have, I used to say 2 ways of becoming an astronaut. One, of course, is the easiest is join the military, become a pilot, go to test pilot school. And even though the newer vehicles we're developing are more automated, we're always going to need that type of a person with their leadership characteristics. And then you can become a mission specialist like me, and you can really study any area of science, although, of course, some you have a better chance with some, like you said, veterinarian. You can still be selected as an astronaut, but your chances are probably not as great. But pick an area that you love first, because it's still pretty hard to get selected because the numbers are so difficult. The most recent astronaut class had 18,000 applicants for 12 positions. So, and I would also suggest that you do things like scuba diving, get your private pilot license, any of those kind of things that show you're comfortable in a different environment than just working in a laboratory. And also, I would learn a foreign language. I think a lot of the newer astronauts who come in knowing Russian or Chinese or something, that's a really advantage. And so that used to be all I would say. But now I say you can also become a venture capitalist or a billionaire and either build your own rocket and fly on your own rocket, or spend a lot of money to go fly in space. And I think it's just really exciting. And now I think also with the space station and all the plans for other space stations that are in work, companies like Redwire can send their own researchers up into space to do their own research rather than relying on a professional astronaut. So I think it's just a really, really exciting time. And the one last thing I'd say is I talk to a lot of women around the world, and men too for that matter, but women are always worried about how they can combine having a family with a demanding job. And so, I just tell everybody that everybody's situation is different, and you just have to figure it out. But there's no reason why you can't do that and enjoy both things. And I think it makes you a better astronaut because you have your family to ground you, and it makes you a better mother or father because you have a job that you love and you're happy.
And as we discussed earlier, your daughter, Kristen Fisher, who was a reporter for CNN, played a vital role in preserving the Artemis program. So you have a family legacy now of supporting spaceflight.
Yeah, I'm really, really proud of her, but she always tells me that I owe the fact that I was the first mom in space to her.
She's got you there. And Dr. Fisher, when you said Redwire sending its own astronauts up, I saw Rich perk up a little bit at that
Private
possibility. So, Rich, Dr. Fisher mentions the transition from the International Space Station to the commercial space platforms, and curious what you see that future of microgravity being, yes, on the ISS and then beyond.
Right. It is a really exciting time in the industry right now. I don't know whether some people have called it the second golden age or is it the golden age. We've never had so many places to go, ways to get there, things to do. There are private space stations being developed, and Redwire has partnered with Sierra Space to outfit a space station that company is building with Redwire payloads. Many of those are going to be doing drug manufacturing in space. You mentioned the flight coming up. I guess it's Thursday. The 29th cargo mission for SpaceX launches Thursday evening. On board, we have some drug manufacturing test devices with our partner Eli Lilly and Company, the drug manufacturer in Indianapolis. And those are what we call pillboxes, which is everything is an acronym within the space agency, right? So pharmaceutical in-space lab, bio-crystal optimization experiments. I think I got that right. Thumbs up. And so what we're going to be doing is testing out some drugs for Lilly in the related to pain, cardiovascular disease, and diabetes.
I've got all of those things right now.
So some tests have shown that drugs, when they're in their crystalline form, those crystals can be grown sometimes larger, more uniform. Some shapes for those crystals, the recipes result in crystals that can only be grown in space. And perhaps in an era where we're increasingly emphasizing personalized medicine, this might be one way to develop a drug in microgravity for a specific patient or maybe a class of patients, category of patients, that you couldn't do on Earth. That enthusiasm that we're seeing from partners like Sierra, from Eli Lilly and Company, we've even seen it from, you mentioned Shepard Fairey, and Shepard Fairey actually developed a mission patch because along with acronyms, patches are the currency of our industry. And I think my friend Patrick O'Neill worked with Shepard Fairey on a terrific mission patch. Yeah, so that's the enthusiasm that's happening right now within the industry. Such a huge crowd we're seeing today at the Space Center is another indication of that. It's an exciting time to be a part of it.
Richard, talk to me a little bit more about the organ fabrication, organoids, and what that regenerative medicine, personalized medicine can mean for humanity in reducing human suffering.
A lot of the organoid work is related also to drug testing and efficacy testing. You can actually manufacture small organs. That's why they're called organoids. So a small brain, a small liver, small other lungs, and then do drug efficacy testing on those biomanufactured organoids. And a lot of tests have shown that it's better than testing on a laboratory animal. It's more, of course, a laboratory animal doesn't have your complete DNA, it doesn't share your DNA, but we can take a sample of you and bioprint an organoid and then try the drug out. Again, personalized medicine. Would it
Certainly
work?
more ethical as well.
Ethical as well, yes.
Wonderful. And, Dr. Fisher, Jess, she talked about sticking with it, tenacity, and that's how you achieve being an astronaut or really anything else in life. You shared with me over lunch a little bit that you were about to leave a certain career path until an opportunity came up. Wondering if you might just like to explore that a little bit and the importance of not giving up on that dream, whatever it may be.
Sure. Yeah, so before I took the job that brought me here, and just in case anybody doesn't know, we're on strike at the moment. The actors union is on strike, which is why we're not speaking about the show. But yeah, I had actually decided to take a step back. I lost. And had invested back into my art for a year before I got the call. The value of sticking with things. Look, I think also have room for yourself to want to give up sometimes. You don't always have to be really excited, but just if you have passion for something, let it be a part of you, even in the times where you don't have the energy to do it. And don't only be driven by that end goal, be driven by what it gives to you every day as you pursue it. Like let the pursuing of it give you life. Let that be enough until the one day when it actually comes to fruition, because I think in that way you're going to be a lot happier and probably make better work in whatever field that you're going to do. So, yeah.
Absolutely.
Is that good advice? I don't know.
Sounds good to me. I'll follow that advice. Rich, coming back to you, we didn't hear from you yet relative to the importance of science fiction. I know you've been in this field for decades. What brought you in and what keeps you going?
I had worked for a company, actually in communications and public relations with great clients. I never thought I would leave. Airports, the UPS Airlines, aviation clients, and actually hired and worked with Chuck Yeager, famous test pilot, for a while, and really thought my favorite movie was The Right Stuff. And so that was the height of what I thought you could do and work in. Then an opportunity came up in my hometown in a non-space community, because now the space industry is expanding beyond Kennedy Space Center, expanding beyond Texas and other places that are more traditional, into places like, believe it or not, southern Indiana, where I was. And essentially, I was driving past a little space company every day for years to go into my normal job, regular job. But I always was looking for an opportunity to work in the spaceflight industry. And so I joined a little company that ended up turning into now part of a large company of about 800 people. And it's amazing that now in some of these small communities around the country, around the world, can impact humanity from those small communities. So now I've been at Redwire for going on 24 years and have seen that the industry needs not just doctors and scientists, it also needs accountants and HR professionals. It's really growing so quickly that even if you're sitting here today and you're not an engineer or a scientist, but you'd like to work in the industry, it's worth pursuing. There's a place for you. We need you. And for the record, I think that every crew should have an artist on board. I think at some point, hopefully, we'll get to the chief art officer on board or something, because we need artists to help us understand and explain what we're seeing, the impact and the value to humanity for what's happening around us. So maybe you're the first. You said you might. I can do it. Okay. So that's sort of, I come from that. I'm not an artist, but I do come from that sort of humanity-centric position of words and their power.
You're an artist with microgravity payloads, Rich. You're the Picasso there. So you've heard a lot from us, but you know what? Before I turn to the audience, I do just have to ask. You mentioned the one veterinarian at NASA. We have a veterinarian. I'd love to hear what that person does.
Rick Lehnhardt. Yeah, he was brought on to help us learn how to take care of animals that are launched on the shuttle and to do experiments and things like that. And so that was what he was brought on for, but he wound up doing 4 space flights and tons of spacewalks and stuff, having really nothing to do with his background as a veterinarian.
But there you go, Kris. Keep the dream alive, and get to space. So this is our opportunity now to turn to the audience. Unfortunately, we don't have a mic for you, but if you want to stand up, ask your question, I'll repeat it. So happy for any questions, sir. That is a great question. And just to repeat it so that those at home can hear, the question was relative to microgravity manufacturing, creating organs, et cetera, in space. Operating in space is very expensive. How do we ensure that it's profitable so that we can continue and sustain those activities?
It's a great question. We've looked at that extensively. First of all, I'll say it's illegal to sell human tissue in this way. So it's a service. I take your cells, take them into space, and then give them back to you in a little bit different format. But we make it from you, service. But the cost, so if you look at the full cost of, let's say, procuring an organ, by cost, I mean, let's say, to your insurance company, for example. Cost of the anti-rejection drugs that you'll have to take because the tissue that's been implanted to the donor is not you. And you may have a lifetime of rejection drugs, which have a cost. Sometimes those drugs have effects that you don't really want, which causes other problems. And then sometimes there are multiple transplants that are involved, whether the first one didn't take, or if the younger person that gets that, there just may naturally be a. So right now, looking at the full cost accounting, it could be close to being the same. And then launch costs are coming down all the time. I think the further we go, once we're ready for the actual transplantation, because it is a research right now, once we get the science ready, I think the launch costs will be so low that I think we'll be definitely coming out ahead. The insurance company will be coming out ahead to use space-made tissue, and let alone for the patient. This is the best outcome for the patient. That's really
Can you hypothetically, will you be able to print bone marrow in space? That's huge.
Yeah, yes. Bones, bone marrow.
And maybe Kris, Rich as well, if you could talk a little bit about the economics of the pillbox and the drug development, because I know with that, the down mass is relatively small, yet the economic health reducing suffering impact will be very large.
Sure. Right. Definitely with an eye toward what's really the most important here. It's really patient outcomes. And there are better patient outcomes, plain and simple, right now. So when we're talking about doing drug manufacturing in space, we're not talking about making tons of drugs in space. We're talking about making thimbles full of space. What we're making are what are called drug seed crystals. So we get that optimal shape that we want to use space to create. And I maybe the doctors can explain this better than I know they can better than I can, but you can take those seed crystals, put them in a batch of other material on Earth, and it sort of copies that crystal form to that batch. And then you take that, put it in a larger batch, and that's how it happens on Earth right now when you're making a drug. You sort of start in small batches. We're just trying to make seeds in space, and you may only need to do it once, and then you can continue to manufacture that on Earth.
You think you described it as like a SCOBY that you use for kombucha? Yeah, or a sourdough starter?
That's exactly right.
Sounds delicious. And I want to emphasize, this is just what we know about. It's tough to make predictions, particularly about the future, and I expect the driver, the real benefits, is probably something that none of us are thinking about right now. So many, particularly medical discoveries, penicillin, were discovered by mistake. So I think the important thing is to get up there, to try, to experiment, to fail, to succeed, and then to change the world.
I think we've had this amazing proving ground, the International Space Station, for more than 23 years. It just celebrated its 23rd anniversary. Now, it's not been designed to be a large-scale manufacturing environment. That's where our partners, such as Sierra Space, come in with their own private vehicles. You've seen the Sierra model. I think there's one over here in the Gateway exhibit, where it's an inflatable. So it's a really large form factor. Once we get on those platforms, we'll be able to scale up from what we've been testing on the International Space Station.
Now, I'm a huge fan of inflatable technology. I practice what I preach, so it's a wonderful thing. Other questions from the audience? Sir?
I'm a meteorologist by trade. A lot of what you guys resonates. But our science training.
I have to say, we hate you at NASA. It's always the meteorologists raining on our parade. Kidding, I'm kidding.
But the other half of that is communication, right? So it's taking that science, putting it into a format that people understand, right? And then driving them to take an action. Sunscreen on, outdoor event, I need to evacuate an area. So I'm curious from your perspective, the communication piece, and what do you see mentioned right up front, right? Somebody says, why do we need $1 billion to do this? Well, actually, this is the reason.
I can say that it's huge. There are people that I meet all the time who have no idea we even have an International Space Station. So I think we're all evangelists for space program, the benefits of it. Some of those people also think that it's a huge portion of NASA's or the federal budget. I think the NASA's budget is less than 1/2 of 1% of the federal budget. And the high point was in the 1960s when maybe it was around 4%. So I think the space program today is providing a great return on investment for the American people, and communicating that is so important. Plus all the discoveries and things that we're making that will lead forward and continue to pay back dividends for decades.
Kris, Dr. Fisher?
One area that I think we haven't really mentioned, and something that a lot of us in the office are involved in, is what it does, how it stimulates our youth. Certainly in the Apollo program, so many young folks were motivated then to study science and engineering. And I think that's another really amazing byproduct. I go all around the world talking with young people, and the minute you start talking about space, even people who don't want to pursue a STEM career but are more artistically involved or writing, they all get challenged and inspired by space. And I think that's one area that we sometimes forget to mention, that space is something that really inspires young folks to pursue careers in STEM fields, and then who knows what things they will discover and do as a result of that. And it's one of the things that I love most now, is getting to have a chance to talk to young folks and encourage them to follow careers in STEM fields.
It's interesting that you brought up communication, because there's internal and external communication. And one of the things that my team focuses on at NASA is designing medical systems. And historically, what we've seen is that the doctors and the engineers didn't know how to speak to each other because they were speaking in different languages. And so what we have done now on our team is we have doctors and scientists and engineers working together to design new systems. And the information that we want to convey, we can use a common language to do that, so that the engineers at NASA who are going to design and build these medical systems in the future can then take that information and make it real. And so I think that our ability to communicate science and technology in whatever language we need to be able to use in order to reach a given audience is important, both internal to NASA and then with the broader community as well.
And let's be clear, we are facing a workforce crisis in government, in the private sector, and in national security. We do not have enough people to execute the plans that we have. You talk about inspiration, so now I'm going to take moderator's prerogative and talk about my mother for a moment, who's part of the NASA Hunch program. High Schools United to create hardware for NASA. And I grew up in Montana. My parents are still there. and she works on reservations to work with the Native American children in the schools to build hardware for NASA that is now flying on the International Space Station. And there were teachers who said the students can never participate in this program, many wouldn't even graduate high school. And I have seen come out of that program not only college graduates, but kids who I'm now working with in the space industry who said none of this would have occurred if it wasn't for the inspiration and the work and the value that I got from space. And being able to go out at night, point to the stars and said, I built that. So very powerful. Diversity is not just the right thing to do, it's necessary for mission success. We all need to come on board and make this happen. And sir, I saw you brought your son. So let's have a round of applause for a good father. And we hope that he won't just be wearing a NASA t-shirt, but a NASA badge or a Redwire badge and a company badge in the future. So we look forward to welcoming the space industry. Running out of time, so last question, sir. You can take us out. So the question is about radiation, and it's a wonderful question, sir, because I have to say, who's seen The Martian? Who saw The Martian? So when the author of The Martian was asked, what is the most unrealistic aspect of this story, he said it was the radiation. That Matt Damon would have had 9 types of cancer before he could eat any potatoes or do anything due to the pernicious radioactive environment. We talked about inflatables, and because those are soft goods as opposed to metallic, it's a great way to cut down on secondary radiation, cosmic rays. But, you know, Kris or Dr. Fisher, would you like to talk about how we can mitigate these radiation effects for future astronauts?
Thanks for the question. I appreciate it. It certainly is a concern. I think that the general consensus now is that it's not a showstopper. So radiation will not likely stop us from going to Mars. There's 2 types of radiation we worry about in space, that comes from the sun, which is solar particle radiation, and then galactic cosmic radiation, which is everywhere. We can shield somewhat against solar particle radiation. We have no technology that exists on Earth right now that can shield us from galactic cosmic radiation. So what we've learned is that if a large solar particle event were to occur on a mission, there are medications that we could fly. There are ways that we could try and protect the astronauts from that event. But the galactic cosmic radiation that's just everywhere, at least today, we don't have a technology to shield that. So instead, what we're going to try and do as much as possible is mitigate the effects of it. And there's ways of doing that through medicines, through nutrition, through different types of treatments that we can fly for the astronauts for that mission. But there is no doubt that the first people who go to Mars are going to have an increased risk on that mission because of that radiation. And their lifetime risk of heart disease or problems with their brain or cancer is likely going to be higher than if they didn't go to Mars or if they were another type of astronaut. So now what we're likely going to do is study it as much as we can. You mentioned animal and human studies that have looked at radiation. We have all of that data. We're going to share that with the astronauts. We're going to give them the choice to go. And then through an informed consent process, if they want to go, they're going to say that they accept the risk, and they're going to do it because the mission is the most important thing. So there are technologies that can help us. There are mitigation strategies we can use, but no matter what, they are going to face an increased risk.
Kris, out of curiosity, have you tried raising the shields?
The shields are down, Mike.
It's always a mistake, especially before the Reliant shows up. But look, one of the other ways that we have to mitigate is to simply go faster and be exposed for less time to this dangerous environment. And what I would ask all of you when you leave the theater today is we're talking about it, you're going to hear about space exploration, join the cause. Be the ones to invent that new propulsion system that's going to protect the astronauts. Become a part of the space industry. It doesn't matter what your skill set is, what your passion is, we need all of you. I'm a recovering attorney, for goodness sake. There was a place for me, there will be a place for you. So with that, go boldly. Let's have a round of applause for this terrific panel. And live long and prosper, everyone.